This is my third video on C2 from the AQA specification, and in this video we're going to have a look at atomic structure and some quantitative chemistry related to that. So remember, atoms are represented in this way. We have the mass number at the top, the atomic number at the bottom. Mass number is the number of protons added to the number of neutrons. The atomic number is just the number of protons. And in an atom, the number of protons and the number of electrons are the same. You do need to know the mass of each of the particles. So remember, the protons have mass unit 1, neutrons mass unit 1, electrons have a very, very small mass. We say it's negligible, which means it's just very, very close to 0, that we don't even need to consider it. Or you could say it's 0, but the best way to say it is very, very small, or very small. The total number of protons and neutrons is called mass numbers, as I just said, and atoms of different elements can have different number of neutrons. These are called isotopes. So remember, with isotopes, you have a different number of neutrons, therefore a different mass number, but you have the same number of protons, therefore the same atomic number. So isotopes have the same number of protons, a different number of neutrons, or isotopes have the same atomic number, but a different mass number. So, for the higher tier students, they also need to know a bit about the relative atomic mass of an element, the AR, and that compares the mass of atoms to the element with so the mass of atoms of the element with a carbon-12 isotope. So 12 should be superscript up here. So a carbon-12 isotope. It's the average value for the isotopes of the element. Okay, so that's the average value. The relative formula mass, okay, that's a bit more straightforward, of a compound is a sum of all of the relative atomic masses, okay, of the numbers that are shown in the formula. So hydrogen, so let's go to these ones over here. So sodium has a 13, and if you add hydrogen with it as well, hydrogen has 1. So sodium and hydrogen together would therefore make 24. The relative formula mass of a substance in grams is known as 1 mole of that substance. So you've got to remember that statement there. The relative formula mass of a substance, so this value over here, if we put that into grams, it's known as 1 mole of that substance. So quickly talking about chemical analysis. When we talk about chemical analysis, we're talking about some of the techniques that we use to analyse some of the chemicals that are used quite often in industrial chemistry. So elements and compounds can be detected and identified using some instrumental methods. These are accurate, they're sensitive, they're quick, and they're useful, especially when you're talking about very small samples. The main industry this is used in is the food industry. Artificial colours can be identified using chromatography, so this is the main area where we use chemical analysis. The big one that we talk about, big area chromatography, so paper chromatography is what you've seen before with colours. The big area that's been used in industry is gas chromatography, and they link that to something called mass spectroscopy. So you generally see this GCMS statement. So you do need to understand this process step by step. So these 3 bullet points here, you need to make sure you understand. So feel free to pause this video and write those down, or just listen as I speak through them and write them down afterwards. But remember, gas chromatography allows the separation of a mixture of compounds. So you've got a mixture of different compounds, and they're separated by this process. The time taken for a substance to travel through a column, okay, is used to identify the substance. So different molecules, different substances take different amount of time to travel through a column. The output from the gas chromatography column can be linked to a mass spectrometer, and that can be used to exactly identify the substances that come out of the column. Okay, and finally, for higher tier students, the mass spectrometer can also give the relative molecular mass of each of the substances separated in the column. Okay, so the bits about quantitative chemistry, so this is like the math side of chemistry. The percentage of an element in a compound can be calculated from the relative mass of the element in the formula and the relative formula mass of the compound. Okay, so if you wanted to know how much carbon was in carbon dioxide, you see what the relative mass of carbon was, and you divide that by the relative formula mass of carbon dioxide, and you times that by 100. So a common done one is the amount of calcium in calcium carbonate. So calcium has a mass number 40. Calcium carbonate, if you add it up, ends up being 100. So therefore, calcium is 40% of calcium carbonate. So there's a statement here about empirical formula. Now, I've actually made another video about empirical formula. So if you're a higher tier student and you want to find out about empirical formula and how to calculate the empirical formula, and also how to find the mass of the reactants
and products from balanced symbol equations, I've got that in a separate video. So on my channel, on the playlist, the same playlist that this is on, look for the video where I've got an exam question based on an empirical formula. Okay, so remember, in chemical reactions, no atoms are gained or lost as long as the system is closed, so the lid's on top and things like that. So even though this is the case, it's not always possible to obtain the calculated amount of product because some of the reaction might not have completed. Okay, so the reaction may not go to completion because it's reversible. So some of them might have gone back to the original products. So some of them might have gone back to the original reactants. So when you're trying to make these products, because the reaction is reversible, some of the during the reaction, some of it might have gone back and actually recreated the reactants that started the reaction off. Some of the products might be lost when you're trying to separate things out, and some of the reactants may react in different ways than expected. Okay, so they're the three reasons why you don't always get the mass or the number of atoms that you'd expect, or the mass of a product that you'd expect. So the amount of a product obtained is known as a yield. So if you ever see the phrase yield, that's the amount of a product that you're actually going to get. If you compare that to the theoretical yield, you can calculate the percentage yield. Okay, so higher tier students will be asked to do that calculation. In some chemical reactions, okay, and I've just mentioned this, sometimes the products can become the reactants. So if you put A and B together to make C and D, sometimes C and D can go back to make A and B. We call that a reversible reaction. The reaction goes both ways. Okay, so ammonia chloride can split apart to become ammonia and hydrogen chloride, but it can also go in the backwards direction as well. Okay, and that ends the video to do with chemical techniques and atomic structure.